Now, we are to multiply polynomials. In multiplying polynomials or algebraic expressions, you need to consider these three steps. Number one, we need to use one of the most important properties when we talk about multiplication of polynomials, and that is the distributive property. Second, we are going to consider the application of the first law of exponent were able to talk about in the previous session, and that is actually the multiplication law of exponents. And third, if there are terms that could be added or subtracted, we are going to use or apply the processes that involve addition or subtraction of polynomials. So let me write it here. Again, the first is the distributive property. Next is the multiplication law of exponents. And finally, we are going to add or subtract polynomials. First, let's talk about item number one before we proceed with the rest of the items here. But the first part of this video will be talking about the process which involves these three steps. I also prepared here an area wherein we're going to use another model, specifically the area model, or what we also known as the lattice multiplication, that you could also use to get the product of these polynomials. But then again, our first concern is with these three steps. Considering in number one, we have here the monomial term 2x to be multiplied to a trinomial expression x squared plus a 3x minus 1. In doing so, we just need to apply first the concept of the distributive property. And what is that? Looking at this term here as the monomial term, we can distribute this to all the terms inside the trinomial expression. And please do not forget that when we distribute terms, expressions, or coefficients, we are actually multiplying it to each of the term that could be found in the grouping symbol. My point is this. When we distribute that, the monomial 2x will be multiplied to the expression x squared. Same as that, we are going to use the same process when we talk about the second term. The same 2x will be multiplied to the second term in the given trinomial, which is 3x. Notice that I am using here parentheses to denote the process of multiplication. And that is actually more important to be remembered when we talk about negative coefficients or terms. I'm talking about the third term here. We can actually apply here minus, and you have here 2x times the third term, which could be 1. You could do that, but there might be some confusions later on as to what is this term really. Is this 1, positive 1, or a negative 1? Hence, I'm going to give you this advice. When we're going to multiply polynomials, always separate the terms by a process of addition. Now, here's the thing. Regardless first on what are those terms that you are multiplying to one another, always separate pairs of terms that could be multiplied by the process of addition. And why is that so? Consider our concept before in the previous video wherein we removed a grouping symbol preceded by a plus sign or a positive sign or the operation of addition. When we try to remove any grouping symbol preceded by a plus sign, it's easier for us later on to, to remove the grouping symbol, since we had that rule that by removing a grouping symbol preceded by a plus sign, all the signs inside the said grouping symbol will not be changed, or in short, they will just be retained as to what are their signs. That is also my point here. I'm advising you to please separate all pairs of terms by addition. Don't worry, later on, whatever will be the product for those pairs you're separating, it might apply later the change of signs if possible. And by doing this, when we add the terms now, it could be implied here that when we talk about terms, as we have talked about in the first lesson of this grading, the signs before the term, or I mean the operation before the term, becomes its sign. Since the terms here are separated by a subtraction, this subtraction symbol could become the sign of the next term, which is 1. This is again what needs to be remembered here. When we change all up, when we use the operations of addition, we can place here the the negative sign from the operation of subtraction in a given. So here is the process again. Distribute the term to all of the terms inside the grouping symbol, and then separate each pair by addition, and always consider that if there are, again, very important, negative terms or coefficients, as we take the sign or the operation before added sign, always use parentheses. Now we have applied the distributive property here, and the next step that we need to apply is the multiplication law of exponents. This is actually observable here when we try to multiply each of the terms in here, or coefficients. As we know that there is the variables here are of the same base, we can use the multiplication law. And the multiplication law states that when we multiply exponentiations of the same base, we add the exponents. Here it goes. First, let's multiply the coefficients. 2 times, again, this has coefficient 1. So 2 times 1 will result to 2. As for the variable, they are of the same base. We copy that and add the exponents. We all know that x here could be written as x with the power exponent of 1. In short, this could be the exponent for this is a sum of 1 and 2. That is for the first term. Second, again, plus, as what we have used earlier. 2 times 3, the numerical coefficients first, you have 6. And then the literal coefficients, x, with exponents of 1 and 1, you will have 1 plus 1. And finally, for the last term, you have 2 times negative 1 is negative 2. And since there are no other variables here that could be multiplied with x and then later on be using the multiplication law of exponents, we just leave it as it is. Don't worry about this grouping symbol because we are going to remove it later. Finally, our result here could be the process of the addition of exponents as declared in the previous step. So you have 2x, 1 plus 2 is 3, plus 6x, 1 plus 1, 2, or 6x squared. And this one, we can now remove this grouping symbol preceded by a plus sign by taking into consideration that when we remove any grouping symbol preceded by a plus sign, the sign of the numerical coefficients inside that grouping symbol will be retained as it is. Since it is plus sign and the operation before is subtraction, so this could be written as minus 2x. Again, if you don't like that analysis, you could always multiply the signs. Positive times negative is negative, or by operation, we use it as subtraction. So we have minus 2x. The last step in multiplying polynomials is to see whether there are terms that could be added or subtracted. Now, here comes the thing. Some of us might think that we could add all of this and probably add all the exponents as well. Do not use the addition of exponents because the addition of exponents is only possible if you are multiplying terms of the same base. Remember that when we add or subtract polynomials, the only thing that we are considering is the likeness of terms. And we can tell that terms are like if and only if they have the same literal coefficient. And by means of literal coefficient, it includes the exponents. So even if they have same variables here, since their exponents are different, 3, 2, and definitely we have 1 here, That would mean that we can no longer add any of the exponents here, and that would mean that this is our final answer. So this is just a process of multiplying polynomials. In number two, we can notice that we have binomial to be multiplied by a binomial here. We are going to use the same three steps here: the application of distributive property, the multiplication law of exponents, and see later if we could add or subtract terms. But there is a good thing here when we are going to multiply two binomial expressions. Again, binomial, we have two terms to be multiplied by another binomial, two terms. And that distributive property is actually with a unique acronym. We call it FOIL. The FOIL method allows us to multiply each of the terms considering this sequence. And what is that? When I talk about f, we are going to multiply the first terms of each binomial. That is why it is called f. The first terms of each binomial. Looking at this binomial here, the first term is w. And for the second binomial, the first term is 4w. So for the F acronym, we are going to multiply the first terms w times 4w. Notice I am using again parentheses to denote the operation of multiplication. This is just for the F acronym, first terms of each binomial. As for O, it stands for outer. And we say about outer, looking at the expression here, they are the terms that could be found on the outermost of the expressions. That would mean it's the first term of the first expression. Let me use another color. The first term of the first expression, and it should be the last term or the second term of the second binomial expression, outermost. That is actually to be multiplied. We have here w. We have here w times 1. That is for O. For I, we are going to multiply the innermost. So after the outermost, let's talk about the innermost pair of terms. And they are the terms that could be found, again, by the name itself, the innermost in the expression. These are these two terms here. So you're going to multiply 4 times, sorry, 4 times 4w. And for the last acronym, you have L. You're now going to multiply the last terms of each expression. Those are the terms of, sorry, let me go back to the inner. I forgot one very important thing. When you talk about the innermost terms, yes, it's 4 and 4w, but make sure that the term here is actually with the symbol of subtraction. Again, similar to number one, when we write here 1, we take the subtraction before it as its sign. So as for this, it's actually negative 4 times 4w. I remember that when you talk about the last terms are negative 4 and positive 1. This is what the FOIL method stands for. We are going to multiply each of this, and then we're going to add. That's the process of distributive property. We're going to multiply the four pairs of terms here, and then we're going to see later on what would be the next operations after this. By the way, FOIL method is actually the term that is used just to summarize that is still distributive property of um, uh, still the distributive property. Let us look at this. Let me copy the same uh, expressions here, and I will see you that it's really distributive property. Looking at this, when I talk about first, f first terms times first term, let me write it, sorry, multiplying that. So you're just basically distributing the first term. And then for the outer terms, you're also distributing this to the term here. Now, for the second term, inner, we're distributing this one here. And for the last terms, you're also distributing that one. So this is the FOIL method again is just the unique shortcut when we talk about the distributive property. And by the way, if you are in confused with your distributive property, look at what we have here. If you could see a smiling person, this is the smile, this is the chin, this part of his or her hair, and probably these are the eyes and ears. That would mean that your FOIL method is correct. Okay, that's just another representation. Again, the FOIL method is just taken from the distributive property still. So hence, we're still applying the first step, distributive property still. Now for the second step, let's apply the multiplication law. This is what will happen if we're going to simplify rather each of the pairs here. So 4, again, there is 1 here. 4 times 1, we'll have 4. And then the product of W and W will be using the multiplication law of exponents. Same basis. You have W, 1 plus 1, which is actually 4W squared. Okay? For the outer, since you only have W and 1, that's W times 1. And what we have learned in the first lesson, you might want to review those videos connected to that, that when we are writing terms, we are to write the numerical coefficient first before the literal coefficient. Because we all know that when we're writing terms or coefficients side by side, that's automatically under multiplication and is captured by this. So we could actually write this as 1W or just simply W. As for I, you have negative 4 times 4, you have negative 16, and you have your W. And finally, for the L, you have negative 4 times 1, negative 4. These are the results when we apply the multiplication law of exponent for number 2. The next here is the last part, addition or subtraction, similar to number 1 where the products after distributive property and application of the multiplication law of exponents, we are to separate them all by plus sign regardless on what are the signs of their terms. So let us try to add all of them into one expression. You will have here 4W squared plus W plus negative 16W, and I have here plus negative 4. So this is for the F, O, I, and L following the FOIL method. But we need to consider if there are terms that can be combined. I'm talking about terms with the same literal coefficients. The first term is W squared. It doesn't have any other pair, so it stays as it is. You have here 4W squared. But the second and the third terms, the products of O and I could be combined as they share the same literal coefficient. And when we do that, do not add the exponents as of this point because we are just adding or subtracting. The adding or exponents are already done here. So we are just going to add or subtract following the concepts in the previous video. You might want to review on that. 1 plus negative 16, you will have here the result of positive negative 15W. I mean plus negative 15W. And finally, you have plus negative 4. To finish, let's just simply remove the grouping symbol and they are all preceded by a plus sign. So they stand as it is for W squared. It's still 15 minus 15W, and here it will become minus 4. So this is the product for number 2 when we multiply two binomials to each other. Again, distributive property is just a FOIL method. Let's proceed to number 3. In number 3, let's apply the FOIL method. So you have here the first terms. It's a product of y times y. The outer terms, it's the product of y times this, which is positive 10. The inner is actually the product of the, again, include negative 10 times y. And for the last terms, you have negative 10 times positive 10. This is the first step. As again, the FOIL method is the shortcut or the unique way to represent the distributive property. Next, let's multiply them and apply multiplication law of exponents if it's possible. I'm talking about the first here. You see I have y and of course 1 plus 1, which will result to y squared. Next, we can just simply interchange the coefficients, literal, literal and numerical. You have 10y. Here, product, you have negative 10y. And finally, you have negative 100 as a product of negative 10 and positive 10. Finally, after this, let's add all of them. It will start with y squared. Use plus a separator as always. 10y, still plus even if it's negative 10y. And you have here still plus even if the result for the last two terms to be multiplied is negative 100. And then we can combine if there are things that needs to be combined. I'm talking about again here. It may not be all of the time, but you might see most of the examples laying here. Not all of the time. Again, I'm repeating, not all of the time. So you will have here y squared, and you have 10 minus 10, which is actually, or 10 plus negative 10 is actually 0. Some of you might still be convinced in writing 0y. But since 0 and y here are multiplied to each other, and when we multiply any expressions to 0, it's 0 itself. So if that would be the case, no need to write the 0y. So just remove that and make use of the last pair plus you have here negative 100. And finally, by removing this grouping symbol, you have y squared minus 100. So as you can see, number two, our result is a binomial as compared to number three is a binomial as compared to number two, which is a trinomial. We still have two items. Let's move down. When you talk about number four, you might see, I don't know, will this use multiplication? And some of you might say, I could use the power law of exponents discussed before, sir, wherein I could just simply distribute that and I could make the square of 3m plus the square of n. Now you might do that, and if you do, I'm telling you it's incorrect because the power law of exponents is applicable to an exponentiation raised to another exponentiation if under the grouping symbol, all of the terms are separated by multiplication. But they are now separated by addition, or even if it's subtraction, you cannot do this. Hence, this is what you're going to do. Remember that if you have, let's look about number three. When you talk about y squared here, y squared stands for y times y as the first result here. It would mean that there are two y's multiplied by each other. And as we all know, exponentiation is the condensed form of multiplication. So instead of writing y times y, we can simply write it as y squared, telling us that there are two y's multiplied by each other. With that sense, if we see this kind of expression, it's not what had happened earlier, but it's actually equivalent to 3m plus n times another binomial 3m plus n. And with this, we can still use the FOIL method here. Again, this is what it should look like. So the F stands for 3m times 3m, the first terms. O stands for outer. You have 3m times n. I, sorry, stands for n times 3m. And the last terms stands for n times n. So these expressions now is the product of the FOIL method, which is also the distributive property. And then multiplication law of exponents or multiplication process allows us to multiply the numerical coefficients first. 3 times 3, I have here Sorry for that. You have here 9 and m, we have 1 plus 1 because there are two m's to be multiplied by each other. Here, since there are no other coefficients that are the same, so we cannot add the exponents of m and n. Please be guided with that. So this stands for 3mn. Again, do not make it mn squared or something like that, since we cannot add the exponents of m and n because they are of the different bases rather. Here, we could also have this n3m, but writing them in the proper order as what we have discussed in the first lesson. Numerical coefficient first, and literal coefficients alphabetically. And finally, n times n is n squared. And to finish this, let's add them. You have 9m, that's 1 plus 1, 2, plus separator 3mn, plus another 3mn, and then plus n squared. Notice that the second and the third terms again have the same literal coefficients m and n. We have m, n, both of them. So here is only m squared, n squared, so we cannot combine them. But the second and the third terms, we can combine them, and we can have the final result, 9m squared plus, adding terms, 3 plus 3, you have 6mn, and finally plus n squared. Again, we cannot combine any of the remaining terms in this trinomial since they are all unlike. This is now the result for number 4. If I may add, this number result for number 4 is also known as the perfect square trinomial. Write it here, perfect square trinomial. This is a perfect square trinomial, as this is actually a result or a product when a binomial is multiplied by itself. The perfect square trinomial is the result when we multiply this. We also call this as the square of a binomial. A square of a binomial. Let's proceed to the last item for this pre-break session. We can notice here that in number 5, we have the expression binomial and another trinomial here. The FOIL method that we have used in numbers 2, 3, and 4 cannot be applied here anymore because the FOIL method is just the unique representation of the distributive property when multiplying two binomials or two binomial expressions rather. Here, one of the factors is a binomial, but the other is not. So let's not use the FOIL method. What we could use here is to go back to the first process originally we used in number 1, which is also the foundation for the FOIL method, and that is actually the distributive property. And how do we do that, sir? First, let's consider the first term. Distribute this to all the terms in the trinomial and separate the products by addition. So you have a times a squared plus, next, a times, take note of the sign, negative 3a. Take it for that. Next, plus a times 1. This is the result when we distribute the first term of the binomial. More or less similar to number 1 here. Distribute mo tayo to this one here. But we are not yet done. Since this is very different from number 1, we have here another term at the second term, and it should follow the same process. Distribute, distribute, and distribute. So to continue, plus a separator, you have 5 times a squared. Plus still, you have 5 times negative 3a. And finally, plus 5 times positive 1. As you can see, let's just have a short analysis. In the process of distributive property in number 1, by monomial to a trinomial, you have 3 different terms separated by a plus sign. Here in number 2, 3, and 4, we have binomial expression to be multiplied by a number binomial expression, after the first step only, the FOIL method, we have four pairs of products. But then again, we have simplified them as we move forward. But the first step, we have four pairs of products as it follows F, O, I, and L. But here in the first step, we have six as we have two terms to be multiplied to three terms. Three terms. That's distributive property for you. Next, let's continue with the application of the correct multiplication processes. You have A here and A, so it is actually A 1 plus 2. We can add the exponents. Here, plus negative 3, as this is 1 times negative 3, and you have two A's, so 1 plus 1. Here, A times 1 is 1A, or simply A. Next, you have 5 times 1A squared, or 5A squared, plus 5 times negative 3 is negative 15A. And finally, 5 times 1, you have 5. These are the results. But if we could simplify it further, 2 plus 1 is 5 cubed, plus negative 3A squared, plus A, plus 5A squared, plus negative 15A, plus 5. Okay? So after we have added the exponents now. And finally, for the last, let's try to see if there are terms that could be added. A cube has no other pair here of A cube, so it stands as it is, A cube. By the way, that's A, not 9. Then for A squared, we have also another A squared here. So combine these two. We have negative 3 plus 5 is positive 2A squared. Again, negative 3 plus 5 is negative 2A squared. Next is A's. You have A and A here. It has 1A plus negative 15. You have here plus negative 14A. And finally, the constant 5. To finish, let's just simply remove the grouping symbol and retaining the negative. You have here A cubed plus 2A squared minus 14A plus 5. No other terms can be combined since they have different literal coefficients. So this is the result for number 5. So the process again, you might have many steps and techniques here. The thing need to be remembered when multiplying polynomials is the application of the distributive property, the application of the correct process for multiplication law of exponents, and finally for terms that are already separated by addition, see if there are terms that could be added or subtracted, and do it to simplify the expression. I still have here second part, another method I could show to you, but that is for the next video. See ya!